in this problem we are given a kind of a differential equation, but again it does not look exactly like a well known differential equation because the coefficients themselves have been defined in terms of a function g of x and its derivatives. And further it is given that y of 0 equals 0 and the values of g is given at 0 and 2, both of them is equal to are 0. We need to find the value of y of 2. So, as I said earlier, it is a differential equation. You can actually consider it as a differential equation in y or even in g, but since we have been asked to find the value of y of 2, we will consider it as a differential equation where y is the unknown function. Then if you consider it like that, it becomes a first order linear differential equation, and we know a very good method to solve it, that is by finding out what is the integrating factor. So, let us try and find out what is the integrating factor. So, that is equal to the coefficient of y of x here. So, e power integral of g prime x dx. So, here we get this is equal to e power g of x. So, this is the integrating factor. So, from here one can immediately say that y of x times e power gx, this is equal to the integral of the RHS. So, the integral of the RHS happens to be g of x times g prime of x times e power gx, since we are multiplying by the integrating factor on both sides, times dx. And this integral is not very difficult to evaluate because one can make the substitution that g of x is equal to u. Then this becomes equal to integral of u e power u du. Here I have made the substitution that u equals g of x. Alright. So, here once you get this, so this we know this is equal to u e power u minus e power u plus c, alright. So, we have got things. So, again there is this e power g of x, therefore, we can cancel it out from the both sides and one can write the ultimate equation as y of x equals, so since u equal to g of x, I can write g of x minus 1 plus c. So, this is the equation which we get relating y of x and g of x. Now, we have been asked to find out what is the value of y of 2, but before that we have to of course evaluate what is this value of c. For that we can put the value of x to be equal to 0. So, we have y of 0 equal to 0 and g of 0 is also equal to 0. So, putting the value of that, we get that c is also equal to 1. So, by therefore implying that the function y of x is actually equal to g of x itself, alright, and therefore y of 2 can be immediately said it is equal to g of 2, which is equal to 0. So, y of 2 is equal to 0 is the right answer. So, again this is a problem which involved differential equations. It is a pure problem on differential equations, just that it was given in a form as to confuse you by putting the coefficients in terms of a function and its derivatives.